So now let us look at the first question 7. Diagram 7.1 and 7.2 show circuits consisting of 3 identical bulbs arranged in 2 different ways. So these 2 different ways, the first way obviously is series connection, and the second way is parallel connection. Series means all the bulbs is connected on the same line. Parallel means the bulb is connected on a different line like this. So name the circuit arrangement in diagram 7.1 for question A. Diagram 7.1 is series, so this is correct. Now we go to question 2, B2. Calculate the effective resistance in each diagram. So for diagram 7.1, it's a series connection. So series connection, the resistance is formula R total equal to R1 plus R2 plus R3. So for diagram 7.1, the resistance is 4 plus 4 plus 4 because it says in the question that each bulb has a resistance of 4 ohm. So each is 4 ohm. So we add up all 3 of them, we get 12 ohm. Now let us look at diagram 7.2. For diagram 7.2, the resistance is connected in parallel. So the formula is 1 over R total equal to 1 over R1 plus 1 over R2 plus 1 over R3, which is also 1 over 4 plus 1 over 4 plus 1 over 4. Because R1, R2, and R3 are equal to 4 ohm. So this, we add them up. 1 over 4 multiplied by 3. We get 1 over R total equal to 3 over 4 ohm. Lastly, it's very important to invert this expression because R total is a denominator, so we need to invert the thing. It's very easy to make careless mistake here, so need to be extra careful and remember to invert to calculate the total resistance for parallel circuit. So now we look at question B2. State which circuit will produce greater brightness of the bulb. So this is the series circuit, and this is a parallel circuit. Which of the circuit will have a bulb that's brighter? Answer is parallel circuit. So why is it so? Because this battery provided to both the circuits are the same. Both get 2 identical batteries. So there's certain voltage provided by the battery, provides certain voltage. For the series circuit, right, the voltage have to be divided among the three bulbs. The first, so let's say the voltage is V, right? The first bulb will get V over 3, second bulb will get V over 3, the bulb. So all of them only get like 1 over 3 volt. On the other hand, for the parallel connection, right? Let's say the voltage is V. All the bulb here will get the V voltage. All 3 bulb will get V. So to make it more simple, let's say that this battery is 9 volt, for example. Then for the series connection, all bulb will get like 3 volt, 3 volt, 3 volt. But then for parallel connection, if it's a 9 volt, all the bulb will get like 9 volt, 9 volt, 9 volt. So From this, we can see that in the parallel connections, right, all the bulb will have greater larger voltage. So if it get larger voltage, the bulb will be brighter. Then this is the voltage. What about the current? So this, what's interesting about the parallel circuit is, if the bulb is connected in a parallel connections, right, the battery will actually supply much more current for each of the bulb. Like for this, the battery will output certain amount of current. The current will have to go through all the bulbs, the same amount. And then for the parallel connection, it will have more current which is shed to each branches. This because if you have the bulb arranged in a parallel connection, as we have calculated here, 4/3 ohm, and then for diagram 7.2 and for diagram 7.1, we get is 12 ohm. So diagram 7.2 has which is a parallel connection, have a smaller resistance. This has a smaller resistance. This bigger resistance. And this is smaller resistance. So bigger resistance means you have the formula V equal to IR. If resistance is bigger, the current will be smaller because the I and R are inversely proportional. They are on the same side, so they're inversely proportional. So in the parallel side, the resistance is smaller, so the current will be greater. So we can say that the larger the parallel circuit here, it has larger voltage. It has also larger current to supply to all the bulb. So we can obviously see that the larger voltage and larger current, the bulb will be brighter. So state which circuit will produce greater brightness of the bulb. The answer is diagram 7.2, which is a parallel circuit. Give 2 reasons for your answer in B2. So why is it the parallel circuit has a brighter? So just now I already explained. For parallel circuit, I already explained here. Each of the bulb actually get a larger voltage. Compare to the series circuit. Right here, the parallel 7.2. It has a larger voltage. This is the first reason. Another reason is for parallel circuit. Another reason is the parallel circuit 7.2 has a smaller effective resistance compared to series circuit 7.1. So if it has a smaller effective resistance for same amount of voltage, provided by battery across the bulb, for same amount of voltage, then the larger amount of current will be provided by the battery in parallel circuit. So lastly, I will also say, since the bulbs in circuit get more voltage and current in total, the brightness will be higher. So this question, if you want to be really safe, you can actually draw out the circuit. You can draw out the circuit, and then you show all the calculation, how the 9 volt can split into 3 volts. So my tuition teacher used to tell me that the examiner will read everything that you try to explain, even if it's in a form of diagram or in a form of calculations. So let's say I were to be taking my SPM right now, I will definitely draw the circuit here and explain how for series circuit, how the 9 volt will split into 3 bulbs. And for the parallel circuit, I'll explain how the effective resistance is smaller. You can see that actually in part B itself, we already calculate the resistance for both the circuit. So next question. Diagram 7.3 shows an illuminating torchlight. It is found that the torchlight is not bright enough even when new cells are used. So a modification is required to make the light brighter. Suggest modification that needs to be done through this aspect. So just now, in this question, we are dealing with the series and parallel connection of the light bulb. But for this question, we are dealing with the cell, the battery. This is this one. So in last question, the battery is in series connection. So what if the battery is connected in like this parallel connection? This parallel. So they are asking us what we need to do to number of cells and the way the cells are being arranged. So to make the bulb brighter, of course we want more number of batteries, because the more the batteries, the more electrical energy is supplied. So logically the cell will be brighter. So we want to increase the number of cells to make the torchlight brighter. So in the previous question, we have 2 batteries. So maybe we want to have even more. We want to have 3 batteries. So let's say every battery is 1 point. Let's say every battery is 1 volt. So if in series 2 battery, we'll get 2 volt. And if we have 3 battery, we get 3 volt. So if we have higher voltage, the brightness will be higher. And also the way the cells are being arranged. Basically, they're asking us whether series is better or parallel is better. So series is better. The reason is because we want a greater voltage, right? So just now we have seen that if we stack the battery in series like this, like 1 battery, 2 battery, and 3 battery, the voltage will also increases. But for parallel, right? So let's say the battery is still 1 volt. It's 1 volt battery, 1 volt battery. In total, if you measure the voltage across the two, it's still 1 volt. Even if you connect like 3 battery in parallel, you still get 1 volt across them, measured like this. That's why we want the cell to be arranged in a series, because we want a greater voltage.